Our guest speaker this evening is a gentleman that I asked come to speak to us because I've been listening to this podcast for several years now. While I don't have a yard with a lawn tractor, I usually listen to it on the train on the way back and forth. The Ham Radio Workbench is a podcast where they normally go pretty deep into various parts of building radio and the electronics and the technology and design behind stuff. Also talk a lot about equipment for the workbench and different things. And I mean, there's a lot of it that goes way over my head, but it's still fascinating to listen to. And I do get things out of it. And even if, even if the particular topic is way up here, it's still fun because they're fun guys to listen to. So with that said, I will now turn the meeting over to our guest, George Zafiropoulos, who is K6.
Close.
To call.
KJ6VU.
Thank you. And I will turn it over to him. He is going to give us a talk about setting up a workbench. Everybody mute, if you would. Over to you, George.
All right. Thank you, Paul. Let me go ahead and share my screen. Hopefully that's up and running. So Paul asked if I do a talk about setting up one's workbench, and there's a lot of things that we could talk about when we talk about setting up a workbench. So we'll talk about mostly stuff. What kind of gear, what do you need, what's necessary or what's optional, what's it cost, and a few suggestions. It's always fun to spend other people's money. So this will be an exercise in making a shopping list of stuff to consider. And if you have questions as we go, please do feel free to unmute and ask questions. It makes it much more fun and interesting for me, and maybe a little bit more interesting for the viewers as well. So just a little bit about myself before we jump into the workbench content itself. I've been a ham for a lot more years than I care to remember at this point. I got my novice ticket back in '72, worked my way up through every class over the years. And mostly what I focus on is building stuff. I've done a lot of repeater building, and currently the trustee of several repeaters here in the Bay Area that our club owns and manages, analog, FM, as well as D-Star, Fusion, and DMR repeaters. I like QRP. I've built a ton of QRP radios. I like QRP operating and portable stuff. I like to build stuff with microcontrollers and so forth. I have built a couple of products which have been sold commercially to the ham world. So I designed and built a repeater control system with a good friend of mine, John, KJ6K, and that's a pretty complicated beast of a multi-ported linking repeater control system. I also designed and built a series of portable antennas called Pactenas, and I'm the co-host, as Paul mentioned, of the Ham Radio Workbench podcast. And I have a lot of radios. I have more radios than I'll ever use, to be perfectly frank. But my main radios are a Flex 6400 and a K3, and a bunch of portable radios, and then the usual mishmash of VHF and UHF stuff as well. So let me touch on the podcast for a moment. Paul did a nice job of introducing it, but just to give you a few more tidbits about it. We have over 130 episodes that we've produced over the last 4 or 5 years. We put out a new episode every 2 weeks, and I don't think we've missed a single 2-week slot since we started this. The shows are supposed to be an hour long. They tend to be more like 2 to 3 hours by the time we're done. And as Paul said too, they're always sort of technically oriented, whether you're a hands-on builder or just want to know how a technology works. And we try to get guests who are experts in the area that we're talking about. So we have a really good dialogue with those folks, and we have a lot of fun. And the whole point of that is that if you're interested in a certain technology, we can go deeper on that technology. And if you're brand new to it, we try to introduce it to you in a way that makes it interesting and perhaps motivates you to want to dig in deeper into that topic. So the whole talk here is about a workbench. So what is a workbench? And when I started out, this is not my workbench, by the way. I wish it was this clean. So the first thing that pops to my mind for me personally is the workbench is my happy place. So when I want to go do stuff in spare time and enjoy my hobby, it's usually more likely at my workbench than at the operating position in the shack. It's really an opportunity to make things with your own hands. It's a great way to learn something and maybe even make something useful at the end of the day. So it's just a great opportunity to learn and have a creative outlet, especially for those of us who like to solder and that sort of stuff. This is actually my workbench. This is what it does really look like. So I've accumulated a fair bit of test equipment over the years. So the bigger ones you see here are service monitors, because I do a lot of repeater work, both in controller design and also building and maintaining our repeater systems. But the usual mishmash of other test equipment, meters and scopes, and excuse me, power supplies, signal generators, soldering irons, and so on. So I've got a pretty reasonable set of gear and also a whole bunch of parts. And there's more than what you can see here, but this is the main workbench space. So when we talk about a workbench, what do we mean by that? And a workbench is a different thing to a lot of different people. So you don't have to have a workbench like my workbench. You can have a workbench that looks like this. There's nothing wrong with a plastic tackle box or a toolbox with a dozen tools in it. I mean, that would make a perfectly fine workbench. And for probably the majority of what any of us are ever going to do, this is really quite sufficient. You don't really need to have a huge bench with a ton of stuff. You could also make something that's a bit more like a real workbench, but portable. So I thought this was a rather clever setup where this fellow put together his own wooden case with a power supply and a soldering iron and some other test gear and parts and a light. And you could still have a nice workspace that's very portable. So your kitchen table could make a perfectly fine workbench if you don't have the luxury of having a big workbench. So basically the point is to do whatever you can do, and it doesn't have to be a permanent installation. In fact, it could be something really quite super portable. I think one of the more interesting challenges is to look at how to make the world's most portable but still useful workbench. And you could even do something like this with a combination of one of these little kits of tools with various screwdrivers, a soldering iron, hand tools, and maybe something like this analog discovery all-in-one USB connected signal generator oscilloscope device that uses your PC as the user interface. We'll talk a lot more about that in a few slides. So you can have a really quite decent workbench that really fits in a drawer. So it doesn't have to be a huge investment, although it's nice when you have the space. So let's talk a little bit about some of the basics. So we'll start with the most fundamental thing, which is hand tools, and it's the usual stuff. And it's stuff that everybody probably already has, like screwdrivers and needle nose pliers and wrenches and all that. We have a whole episode in episode number 2, in fact, was all about hand tools. And the first 10 episodes of the podcast, we focused on the basics. So I'll be referring to a lot of those first 10 episodes in this presentation, but also some of the other episodes later on that were more advanced versions of those topics. So a whole episode here on hand tools. So most people already have this stuff, but a lot of times we have stuff that's really mechanically oriented and not appropriate for electronics. And so getting some hand tools that are purpose-built for electronics, like wire cutters and needle nose pliers that are a bit finer, is certainly a big plus, and I'd suggest people do it. These pre-assembled kits of Chinese tools are really a deal. So for people on a limited budget, if you're a student or for whatever reason, you want to keep it inexpensive, you can get some great kits of tools for next to nothing. And of course, if you want to get really professional grade stuff, the sky's the limit on buying more expensive versions, but you can get a decent set as a starter kit. The second thing that you really need is a soldering iron. So there's almost no project I can think of that doesn't require soldering at some point or another. And we've had endless debates on our podcast about what is the best soldering iron. And for the last 40 years, my stock answer was Weller. So I've been using Weller soldering irons for many, many, many years. They're great. In the last several years, we've seen Hakko become a very popular brand. I have both Hakko and Weller irons myself. At the moment, I'm really a big fan of the Hakkos. I think if I were making a single recommendation for a soldering iron, I would go with the Hakko 888. It's a very popular iron. You can see it's in the upper left-hand corner. It's a temperature-controlled iron with a digital display, so you can set the temperature you want, and it's well regulated. So for about $100, it's a great soldering iron. If I had the choice of spending very little money and could only afford a cheap soldering iron, I would save my pennies to buy one of these and just bite the bullet and get a good one. You won't regret it. We had a whole episode recently, I forget the episode number, about 10 episodes ago, that was about setting up a workbench for $250. And so about 6 of us all got together, and we all showed up with our list of our favorite things to buy, brands and model numbers. And so that's a great reference show to go listen to. The soldering station on the right-hand side is a more expensive one. That's another Hakko. That one is really designed for very fine pitch surface mount soldering. You could do that to some extent with the one on the left, but if you really want to do very fine soldering, then you need something a little bit more precise. So that's not necessary, but if you get into a whole lot of board building with a lot of very small parts, that's something you might want to consider. By the way, one thing that you also see a lot more lately, see in the Hakko cradles, you have that like ball of what looks like steel wool or whatever that stuff is. So it's become more and more popular to use that to clean the tips rather than to use a wet sponge. So I grew up using a wet sponge as you're supposed to, and now I've pretty much switched over to using these cleaning balls, and they do a really, really good job, and they don't cool the iron tip off at all. So that's another advantage of using those. So this is an optional item. We talked about this in episode 54. This is a desoldering tool. And when you first look at this thing, these are pretty expensive. They're around $250. And it's a vacuum pump desoldering tool. So the tip gets hot and there's a hole in the tip. You put the tip over the solder joint, you pull the trigger, and the thing sucks the solder up into that transparent chamber. If you do a lot of building, this is a luxury item that I would really recommend you consider. I build a lot of boards, and often I will come up with a new design. I'll prototype it. I'll make a circuit board because they're really cheap. I'll build the circuit board, and there'll be something I want to change. I'll do another circuit board revision, and then now I'm stuck with all these parts on the board that I'm not going to use. Well, with the solder sucker, I can pull the parts off. Now, most of us grew up using these really chintzy $10 vacuum solder pumps or solder suckers where you push down the plunger, you hit the button, and it tries to wick up the solder. Those are terrible. They never work right. The next best thing is solder wick, where you heat up the joint with this braid, and through capillary action, the solder gets sucked up or wicked up into the solder wick. The problem with that is you bake the living bejesus out of your solder joint, and you have a good chance of damaging the board, the traces on the board. So this solder sucker is just amazing. And if you want to suggest a Christmas present, because it's too expensive to just go out and buy one for yourself, put this on your Christmas list, and you'll really you'll thank yourself for getting one of these things. I couldn't say enough good things about it. The next thing that you want to do is get a multimeter. So after the soldering, oh, by the way, I forgot to mention, get a soldering station, not just a soldering pencil, because the soldering station will be better temperature controlled, and you'll have a better experience. Right after the soldering station, you need a good meter. Now, when I was a young ham, just learning stuff, we didn't have digital multimeters. We had analog, we called them voltometers, VOMs, and they're perfectly fine. These days, you can still get mechanical meters, but for most purposes, a digital one is better. There's still reasons to get an analog meter. We did a whole episode 4 on meters, analog and digital. You can spend anywhere from $5 to $300 on a digital multimeter. And so a lot of guys getting into this ask a very rational question, which is like, wait a minute, this is a voltmeter, that's a voltmeter, this does ohms, that does ohms, this does some current, that does some current, this is $5, this is $250. How much better could it be? And the answer is, well, it depends on what you're doing with it. If you want, if you can only afford, a small amount of money, you can get a great meter for nothing, for under $20. I mean, perfectly serviceable. Why would you get a $200 meter? The two main reasons are, number one, the more expensive meters tend to be built better, which means that all of the contacts internally will be better. You'll have less contact resistance. The connections won't fail as easily, et cetera. So they're just better. You know, they'll build a switch out of a switch as opposed to fingers on a circuit board, that sort of thing. The other thing is that there will be some features of the more expensive meter, like there'll be more digits of resolution, or it'll be an RMS measuring meter, which is something most of us don't need, by the way. What does that mean? When you're measuring an AC voltage, if the sinusoidal wave is a sine wave, in other words, 50% duty cycle on and off, like the AC out of the wall, then RMS does you no good. You're measuring the AC voltage, you'll get a number. If you have a sine wave where the duty cycle is not 50%, then a normal AC meter won't measure it and give you the right voltage. So a RMS meter will. So you always pay more for that. Now, how many of us need that? Like almost none of us, to be perfectly honest. Because most of the time when you're measuring AC voltage, you're measuring the AC outlet in the wall. You're rarely measuring small circuit AC voltage. You're going to use an oscilloscope for that. So you don't need the fancier meter. A great example is a Fluke 101, which is their beginner meter. Fluke is a very reputable brand. They make great meters. This one is $49 on Amazon. You can't beat it for the price. It doesn't have the greatest resolution, but quite frankly, we're not looking at lab grade instrumentation here. We're just looking at good enough. And for $49, you get a good meter by a good manufacturer. It's hard to beat it. And when you go to Amazon or wherever and search for a digital multimeter, there's hundreds. And they're almost all by companies that no one's ever heard of before. And I can't honestly tell you one's any better than the other. So pick a price point, pick a color that you like, and go for it. If you want to spend more money, get something like a Fluke from a reputable brand, and that's a good thing. Personally, I always have one really good quality portable DMM, and then I have at least one cheap one. And a great cheap one, by the way, is from Harbor Freight. For about $6, you can get the world's cheapest DMM. And when you loan it to your friend at field day, you will never see it again, but you won't really care. So that's my recommendation. Don't take your good meter to field day. Take your cheap meter, because someone's going to leave it in the rain or in a bucket of water, and you don't want to have that happen with your nice meter. Okay, the next kind of meter you might consider, this is really very optional. You don't need this, but it does make for a nice upgrade for the bench, and that is more of a bench caliber meter. When you get into these meters, you're really talking about a significant bump in price. You're going from a handheld DMM that's like up to a couple $100 now into the range of a couple $100 to several $100. Why would you bother with this? These instruments are going to be more accurate. They're going to have more digits of resolution. And if you really are interested in making precise measurements, then this would be something to consider. Most of us, I would say almost all of us, don't need this. Because what are you really measuring? For the most part, you're going to say, well, what's the voltage on the battery? Is it 13.8 volts or 12 volts or 12.2 volts? The closest we're going to look at is like a tenth of a volt, maybe a hundredth of a volt, maybe. You don't need to go out to 6 decimal places. Who needs that? I mean, if you're really a design engineer and you're really testing the heck out of something that maybe you have a special use case for it, then go for it. And they look nice. And if you got money to burn, what the heck? But I rarely find the need for anything like this. But it's nice to have if you have the money. Again, we talk about this in a couple of different shows. Brands that we would recommend in this space are Digilent and Rigol. You'll hear those two brands over and over again. What you tend to find in the test equipment industry now is there's kind of 3 tiers of vendors. There's the traditional high-end vendors that we all know, like Agilent. Well, it used to be HP, then Agilent, now Keysight is a top-tier brand. Tektronix is a top-tier brand. Fluke is a top-tier brand. A click down from there would be Chinese manufacturers that have a presence in the United States that do very good service. And those are companies like Digilent and Rigol. So you can buy those with confidence. They're very good products. They're very good price performance points. You can buy them online. You can buy them from really reputable dealers. A great dealer, by the way, if you want to talk to a human to buy your test equipment, there's a company called T Equipment, and they'd be happy to tell you all about what to buy if you want to call them. And their prices aren't bad. The third tier are companies that we've never heard of before. And after a year or two, you may never hear about them again. There's dozens and dozens of Chinese test equipment companies that make things that are similar but less expensive. And if this is really a trade-off of known quality vendor, Rigol, Siglent, and above, versus companies you've never heard of. And some of those companies you've never heard of make great products, so they're not bad. But you don't know them, and most people don't know them, and so you're just going to kind of roll the dice and hope for the best. But that's not a reason not to get them. But you kind of have to make that judgment for yourself. The next thing you want on your bench is a power supply. There's actually different kinds of power supplies, and of course there's high current like radio power supplies, but then there's bench power supplies for smaller electronics. So what you really want is a power supply that is a variable voltage DC supply, something that lets you go from 0 to at least about 20 volts, if not higher, and that is current limited, so that if you accidentally short something out, you don't have a catastrophic failure on your bench and flame up a resistor or a trace on your circuit board. One of my absolute favorite power supplies of all time, I don't think they make it anymore. You can buy them used on eBay. It's made by B&K, and it's a model 1601. And why is this my favorite meter? The reason it's my favorite meter is the voltage range goes from 0 to 50 volts. I've never used anything over 30, but okay, so it's got a good range. It'll deliver up to 2 amps, which is a reasonable amount of power. The most important thing about this meter is the current limit is adjustable. So you can say, I don't want to pull any more than 100 milliamps or half an amp or 2 amps or whatever. And when the power supply supplies more than that current that you've set as the limit, it will pop a resettable breaker. Now, the funny thing is that feature is not available on even $400 Siglent power supplies. So most of these commercial power supplies, even the really good ones, will current limit, but if you hit that limit, they'll just deliver that much current. They don't disable the output, which surprises me, frankly. That seems like a pretty fundamental feature that they don't have. But anyway, a current limited bench power supply is very handy. I would have a couple. Actually, I do have a couple because you might have different voltages you need to apply to your test circuit. So that's a good option. If you again go on eBay or on Amazon and search variable voltage power supply, there's hundreds of them. And now here's a case where you could buy a power supply from a company you've never heard of, and it'll probably be perfectly fine. Because what's to go wrong? I mean, there's not that much to goof up in the power supply. So unlike buying, let's say, a no-name oscilloscope, I would not have a problem buying a no-name power supply. So these are some examples of other brands. Like on the left-hand side here, this is what Tex Power. I don't know. Somebody probably makes this and sells it under 15 different names. It's a 0 to 30 volt power supply, 0 to 5 amps. They're about $80. That seems like a pretty good deal to me. For $80, how can you go wrong? I'm not suggesting this model or this brand. This is just an example. There's tons of them like this. The one on the right-hand side is a step up. This is a Siglent bench power supply. This one is 0 to 30 volts at 3 amps for 3 times the price. So you might ask yourself the question, okay, well, why is it 3 times the price? The first thing is this is a multi-output power supply. It's got 2 outputs, not just one, so that's handy. And the levels are independently settable. So you could go get one of the ones on the left, and then if you need a second one, you get a second one. Or you could just buy this combo to the right here. The other difference is that the quality of a Siglent or Rigol or other name brand power supply is something that you could really rely on. So the metering will be accurate, the ripple in the power supply, the noise, et cetera, will probably be perfectly fine in a good brand power supply, and you're kind of rolling the dice on the cheaper ones. But again, for power supplies, for most applications, the cheap ones are perfectly fine. I'll take a quick pause here. Does anybody have questions so far?
Yeah, you guys have almost talked me into getting that desoldering thing.
Oh yeah, I could have. I actually we did at the Ham Radio Expo at the QSO Today Ham Expo. We had a offline meeting or online meeting room where people can come and hang out. And so at one point I was in the garage and turned on my webcam pointing down on the bench, and I was working on a project while everybody was talking, and I'm desoldering parts, and that like everybody stopped like, what are you doing? And so I demoed the desoldering gun, and I think 3 guys bought it. Like on this,
Yeah.
I should be a dealer.
Yeah, I've got my workstations or Metcals that I got from. I used to work for a part-time for a guy who had industrial surplus, and we get pallets of electronics in from places. And so I got several Metcal workstations, and one of them is a desoldering thing, but I have no instructions as to how to hook it up to an air source.
Hmm.
So it's just a gun without, I don't know. So that
Yeah.
Hako looks really nice.
Oh, it's great. I can't say enough good things about it. Yeah, Metcals are wonderful soldering irons. I generally don't talk about them because um, they're too expensive for
Yeah.
most of us unless you find a good surplus deal. And they're to be had. The guys in the flea market at Dayton, when it was in Dayton at Xenia, there's always guys selling Metcals
And the tips.
tips. Yeah.
No, yeah, I would not have one if I didn't work for that guy.
Yeah. So it's good to know somebody in the business.
Yeah,
So let's talk about the other kind of power supply. This is really a radio power supply, of course, and you want ideally a separate power supply from your normal station. You could use your station supply. So for a bench supply, you can go with a classic linear regulator like an Astron power supply, which are great, or you can get one of these smaller switching power supplies. For bench purposes, they're perfectly fine. I actually use the PowerWorks one here in my normal station for some of my radios, and they're fine. So these are all really good power supplies, and you can always find good deals on these used. There's a lot of them around. People upgrade to have bigger ones. I'd get one that handles 30 amps. You want to be able to comfortably handle, let's say, a 100-watt HF radio, for instance. So a 30 amp intermittent supply would be just great. Having a meter is handy, by the way. You rarely, if ever, need a meter on your station supply, but for a bench supply, it's nice to have a current voltage meter. Another thing that's really handy to have is a DC power inline meter, and there's several different ones like this on the market. These are my 2 favorites for very different reasons. The one on the left is a West Mountain Radio Power Check. This is a really awesome accessory to have in your station. It's rather expensive. I think they're under $200. I'm not sure if I think they're less than $200 now, but something like that. This little guy has power pole connectors. You can put it between your battery and your load, or a power supply and a load, and you can cycle through the display in various forms. You can look at the voltage, you can look at the current. It will calculate amp hours from the time you reset it. It also very nicely has a USB jack, and they provide software, so you can put software on your computer and plug it in. And let's say, for example, if you want to see what the discharge curve looks like on your battery over a 12-hour period or something like that, you can stick this in line, have it log the data to your PC, and then you can see exactly what the discharge curves looks like. So it's, if you're really getting into bench kind of stuff, it's actually very handy. So I use it a lot, but I don't leave it permanently installed anywhere because it's too expensive. The one on the right, however, is $10, and it does almost the same thing. And when I buy the one on the right, I buy like 5 because why not? And I give them out as Christmas presents to my ham buddies. It's almost the same thing in that it measures the same stuff. It measures voltage, current, amp hours, watts. There's actually a jack on the side, which I think you can actually hook to a PC. I've never done it, so I don't know if it's easy to do or if the software is any good. I've never tried it. The only thing you have to do is stick a connector on it because the pigtails come tinned with no connectors. So I put power pole connectors on the ends, and we're off to the races. And for $10, man, you really can't beat it. Everybody needs to have one of these. I have one on the bench just because I'm always putting it on something I'm testing. I have another one in my Go kit. I've got another one in my Field Day kit. So you just get a handful of them. Okay, let's get into the mother lode of useful instrumentation here. Anybody that does anything on the bench, if in any serious fashion, you really need an oscilloscope. An oscilloscope is your eyes into what's happening in a circuit in a way that nothing else can. And so I'm going to spend a fair bit of the rest of the presentation talking about oscilloscopes because it's such an important thing. Oscilloscopes essentially give you a two-dimensional graphical view of typically a voltage on the y-axis over time on the x-axis. So what you can do is probe a signal and measure the voltage just like a voltmeter, but it shows it to you, in the vertical axis where that point is. And over time, it draws a line on the screen as you're taking samples. So everybody's seen the oscilloscope before. You see a sine wave or a square wave or some white noise. You hook it up to a speaker, you can see the voice modulating on the oscilloscope, all that sort of stuff. The reason why the oscilloscope is essential is that if you're working on a circuit, if the circuit is working or not working, sometimes the problem is simple. Like, oh, my power supply blew a fuse. I got no voltage, right? A voltmeter is perfectly fine for that. However, if you're listening to a signal out of a receiver and it's distorted, a voltmeter is not going to help you at all. It's too blunt of an instrument to tell you much of anything. What you really want to do is look at the waveform of that audio signal. Is that signal being compressed? Is there noise on it? What's going on? If you have digital signals, let's say, for instance, I do a lot of microcontroller projects where I have maybe a PC is talking to my remote antenna relay switch, and I send a command through the serial port to the switch and nothing happens. Well, the first thing I want to do is I want to know, is there any data coming out of the computer? If I hook up my voltmeter, I can't tell because that little blip of signal goes by so fast, the meter can't react in time. If it does, it looks like noise to me. So I need to put a scope on that pin, hit the button, watch the data come out of the computer, and I can see, oh, I did see some data coming out. So at least I know the data is coming out of the PC. Now I go to my little switch, my little antenna relay switch, and I can start to trace the path of the signal. Does the signal make it through the connector? Does it go from the connector into the microcontroller? Oh, it made it to the microcontroller pin. At least I know data is getting into the microcontroller. It must be a software problem. So the oscilloscope shows you not only what the signals look like, but defects in the signal. Is my audio distorted? Is my power supply? Here's a great example. I'm looking at a power supply voltage. It doesn't quite seem right on the meter. I look on the oscilloscope, maybe I've got some ripple on it, or maybe I only have half the rectifier circuit is working, and so I'm getting a half of the sine wave is being rectified. No wonder it's all raspy. An oscilloscope helps you see that kind of stuff. So what do you really look for? Oscilloscopes typically are two channels, the most common ones. You can get one channel, two channel, and four channel scopes. One channel scopes are pretty much old hat. Almost everything you'd buy these days has at least two channels. Fancier versions like the one in the picture here, this Rigol has four channels. Now, why do you need more than one channel? Depends on what you're doing. So probably most of the time you need just one channel, but for applications I do, and I'll show you an example in a minute here, having two or three channels, it can be very helpful. The second spec that you look for is what the bandwidth of the scope is. Now, when we say bandwidth, what we really mean is what is the highest frequency that the oscilloscope can accurately represent? And you have to really look at the spec because a lot of times that number is the 3 dB roll-off point of the scope. What that means is that if I say this is a 50 megahertz scope, if I have a signal that's switching at 50 megahertz, I could actually see it with the scope either correctly or as poorly as half of the signal amplitude. And any faster signal than that, the amplitude will be lower and lower and lower and lower. So I'm really not reading it accurately at all. So the bandwidth just tells you how fast is the fastest signal you can really observe with the scope. Now, they tend to start at 50 megahertz and go up. So typically you find 50, 100, 200, 500, a gigabit. How fast of a scope do you need depends on what are you looking at. What kind of design or debugging work do you do? If you are doing typical ham radio DIY projects, you don't need a fast oscilloscope. In fact, you probably don't need anything faster than 10 megahertz. So you can go get a free oscilloscope from your buddy who's looking forward to getting rid of an old scope for free because he has an extra old Tektronix oscilloscope he'd be happy to give you. Often happens. and that's perfectly fine. So why is a 10 megahertz scope good enough? The reason is because if you're looking at audio, what's the highest audio frequency you listen to? 3 to 5 kilohertz. And if you want to oversample that, look at harmonics, you're looking at 10, 20 kilohertz, you'll never hear it. I think a 10 megahertz scope is more than adequate to listen to a 20 kilohertz signal. If you're looking at digital signals and you're looking at, let's say, on a microcontroller, a digital signal that turns on a relay is like at no speed. So anything will work. A voltmeter would work. If you're looking at, let's say, data, like on a serial bus, a serial port, or an I2C port, or something like that, you're looking at thousands of bits per second. You're looking at less than a megahertz. There's very few things that we look at. Now, you might get into something like, in my receiver, I have an oscillator, and that oscillator is at 8 megahertz. So you can use a scope to look at the oscillator and see if it makes an 8 megahertz signal. If you're generating a higher frequency signal, you need a higher frequency oscilloscope. But again, most of us, unless you have a very specific purpose, don't need that. Now, it turns out if you went to the store to buy the standard off-the-shelf common most popular oscilloscope these days, they all start at 50 megahertz and go up. So you can't really get a slower scope for the most part. The other thing to look at in a scope is the size of the screen. And as the cost of electronics has gone down over the years, the oscilloscope screens have gotten bigger and the price has not gone up. So we get now beautiful large color displays. So that's a big plus. Some of the devices also will have the ability to decode digital signals, like some of these serial buses or ASCII in a conventional serial connection. A lot of these can be connected to a computer. So I either have a USB connection or an Ethernet connection where I can hook it up to a computer or hook it up to a network and remotely capture data. Just like my example of that voltmeter, the logging voltmeter, I could do a lot of the same things with an oscilloscope too. Personally, I never do that. I've never run into the need for that, but you could if you really try hard enough. I'm sure you can find an application. So here's 3 different kinds of oscilloscopes you could consider getting today. The upper left hand is the conventional analog oscilloscope. This is the oscilloscope we all grew up using. This is a CRT, cathode ray tube kind of a display. Here, this little example, this shows, I think this is a Tektronix. You see a triangle wave and a square wave. This is kind of the old-fashioned kind of oscilloscopes, and they're kind of big. They're like 1.5 feet deep. They're pretty good size. They're perfectly fine for everything we do. You don't really need anything better than this. You can take a perfectly good 30-year-old Tektronix oscilloscope, and that's all the scope you're ever going to need, quite frankly, unless you have a very special application. Now, if you want to buy a new scope, you're probably looking at something in the lower left-hand corner, a digital oscilloscope, which uses an LCD display. And it uses a very different kind of circuit inside where it's using an A to D converter, an analog to digital converter, that's digitizing the signal and then displaying it on the screen. Now, the digital oscilloscope and the analog oscilloscope could basically do the same thing. Why would you want a digital scope? Well, there's a couple of reasons. First of all, you can build in more features more easily in a digital scope. So I can, in addition to the waveform, I can also bring up on the screen numerical information. Like for a particular channel, what's the average voltage, or what's the peak to peak voltage, or some other measurement that's very easy to do with a digital scope. You can do it with an analog scope, but they were really the high-end scope, so you don't find it as much. Also, with a digital scope, you can do protocol decoding. If I have a serial port or an I2C interface or something like that, you can probe those signals and it'll decode it and show you the values on the screen. The other thing that's really nice about the digital scopes is they're very shallow. So they look the same from the front, but if you look at them on the side, the digital scopes are like 5 inches deep, maybe, whereas the analog scopes are like 20 inches deep. So if you have a limited space and you want portability, you can have a really nice desk instrument that has a very shallow depth. So that's really cool. The third kind of scope that is becoming very, very popular is a headless scope. This is where the oscilloscope electronics is in a package, in a little box, and you basically have a USB connector on one side and scope probe BNCs on the other side, and all of the electronics, the same electronics that would be in the digital scope in a box, are in the little headless scope, but rather than having the buttons, knobs, and the display be on that unit, it uses your computer for that purpose and gives you exactly the same kind of features as a digital scope, but without the physical packaging. Now, in some cases, that will reduce the cost because it reduces the cost of the manufacturer. You don't have to have a big box. You don't need a bunch of display stuff, right? You don't need that screen. You don't have knobs and buttons and switches. So it reduces their cost to build that. So they can essentially reduce the cost to you. The tricky part about these USB connected scopes is that the most important part about it is the software. The hardware, you could look at the data sheet and go, oh, okay, it's a 20 meg scope or a 100 meg scope. It has so many samples per second. You could look at the hard features and you assume that they're adequate quality. What you can't measure is how intuitive and easy is the software to use. And there's quite a variety here. There are some brands that have superb software and some that have terrible software. The one that I'm showing in this picture is a big favorite of mine. It's called an analog discovery, and I'll show you some screen snapshots of that guy. It's tiny. That thing is the size of a deck of cards. It's connected by USB, and all the instrumentation interfacing is on the front bottom edge of that unit. It's a 30-pin header connector, and you can snap on an optional BNC expansion board or whatever you like. So it's a multi-use instrument. It's not just an oscilloscope. It's got about 10 instruments in one. So primarily it's a 2-channel scope. It's also got a 2-channel arbitrary waveform generator, which means I could generate a sine wave or a square wave or noise or whatever. It's got a low frequency network analyzer if you're doing filters like non-RF filters. It's got DC or other individual bit controls to do digital control, like a logic analyzer input or a digital controlled output. It's got a ton of features and some really superb software. These things are not cheap to get a good one. They're about $300. We actually did a deal with Digilent where they're not a sponsor. We have nothing to do financially with them at all. We don't get anything for this. We just love it as a product. So we approached them and said, hey, would you give our listeners a deal? And they did. So there's a bundle that's $450, and they gave us a discount code. And if you use the discount code when you buy it, it's only $325. And for me personally, knowing what I know about I have all the instruments that I've showed you, I have, so I can, and then some, so I can compare. I could tell you that the instrument that I go for the first constantly is this one. Even though on my bench I've got a Rigol oscilloscope and I've got some old Tektronix scopes and stuff like that, I grab my analog discovery every time because I love the software. So they make a couple different versions. This is a different version. It's more expensive. I don't necessarily recommend it because you don't need it, but it's the exact same instrument in a metal box. And then there's a prototype space that sits on top of the metal box. And so you can see the upper right-hand corner has the scope probe inputs 1 and 2, and then the waveform generator outputs 1 and 2 to the right of that, and all the digital I/O on the header in the middle has power supply built in, just like the little puck. So it is exactly the puck in a metal box. The nice thing about it is that it's convenient to have the prototyping space all integrated together, and that white board unplugs, and you can pop another one in there. So you can prototype your circuit and then unplug it, put it on the shelf, and take a blank one and plug it in and do another one, and still keep the first one, and until you just rip it all apart again. So this is quite a bit more expensive. It's really designed for the educational market. It's intended for universities that have labs, and every student would use one of these in the lab, that sort of thing. But it's another option. They have also recently come out with a third model that's even a further step up. That's just a box, traditional headless instrument, but it's got 4 oscilloscope channels on it in addition to the signal generator. So it's got even more. It's a 4-channel scope and a very nice unit. Now, here's why I love this thing. So this software runs on PC, Mac, and Linux. So that's the first question anybody asks me, like, what does it run on? The answer is everything. So stop complaining, you Linux fans. Now, I happen to use it on Windows, but it runs on everything. Now, every one of the functions that's built into this guy here, the 2-channel oscilloscope, the waveform generator, the power supply, data logger, logic analyzer, pattern analyzer, I/O controller, network analyzer, and low frequency, not RF, spectrum analyzer, all of those instruments are displayed in a window. And you can pick any one or all of those instruments to be on the screen, and you can move the windows around. You can make them whatever size you want. So you can make your whole PC screen nothing but the oscilloscope. Or you can say, like in this example here, the upper left-hand square is the 2-channel waveform generator. So channel 1 and 2 are generating 2 sine waves. And if you look to the left of it, it tells you the wave shape is sine, the frequency is 2 kilohertz, the amplitude is 1 volt, etc. Look at the one just below that, the frequency is 1 kilohertz. So that's the waveform generator. Down below that is oscilloscope channel 1, where you see that nice sine wave. And then off to the right is another waveform. This is just noise that we're looking at on the scope. So again, multiple channels on the oscilloscope. Oh, in the upper right-hand corner, this is the digital I/O panel. So those 16 pins on the header could be set to be inputs or outputs. And you could either think about these as like LEDs to look at the logic state, or you can use them as buttons or switches to set a logical state. So if you're working on a digital circuit, it's very convenient. The other thing that's nice about this software is that, first of all, it's very intuitive, but there's even a whole scripting language, so you can write programs to control all these instruments, to do sweeps and do a very, kind of comprehensive test suite if you want. So sky's the limit. This is just a simple example here where I've got 2 windows on the screen at once. Upper left is the oscilloscope, lower right is the signal generator. The simplest example is you take the SIGGEN probe and the scope probe and you hook them together and you generate a signal and feed it back to itself, and you could look at it. And so it's fun to play with. I use this to teach people how an oscilloscope works because it's so simple and so easy to do, and you're not baffled by these 50 knobs, and I don't know what the heck these knobs do. All that is made very straightforward on the software. So, so in summary on the scope, so what should you look for in a scope? Well, first of all, you look for bandwidth. Anything 10 megahertz and above, which is essentially anything you can find, is really good enough for most things. You rarely need something better. 2 channels is perfectly fine for most of us, unless you have a special purpose and need another channel or another 2 channels. The top brands to look for are Classics, Tektronix, HP, Agilent, Keysight, or the very popular, well-supported brands, Reichel and Siglent. And I consider those prosumer brands. They're really meant for the educational, consumer, low and industrial market, but they're quite good. And then there's these PC-based ones like Digilent, which is my fave. Any questions on scopes before we kind of go to the last section here?
No.
Doing okay? Paul, are we on track?
Yeah, we're doing fine.
All right, good. Okay, so enough on the instruments. What else do you need? Well, as hams, we need a dummy load. Dummy loads are relatively inexpensive. You really just want a big non-inductive resistor with a way to dissipate the heat, enough heat depending on your transmitter size. So there's some really reasonable ones to get, like you can go buy a new one from DX Engineering. You can buy a Vectronics, 1 kilowatt dry dummy load. It's fine. You can get a Cantenna. They've been making Cantennas since before I was a ham. Another thing you could do is get a commercial load used off of eBay. I've bought a number of these you see on the right. These are actually taken out of 2-way radio systems. They're used as loads in circulators often, where you have maybe a 100-watt transmitter and a circulator, and the return RF is shunted off into a load. Sometimes they're little 5-watt, 10-watt loads. These are 25-watt loads. So since these are removed from service, they're very good quality. They're very precise in their impedance, and they're cheap, $15. I mean, you can't beat that for a nice little bench load. This is especially useful like on VHF and UHF applications. Okay, the next thing you really want is a watt meter, and there's a lot of choices in watt meters. The choices really kind of boil down to what frequency range and how much power do you want to measure. So most of us want to be able to measure 100-watt HF transceiver, maybe some of us a kilowatt. I don't have that problem. I don't have an amplifier. I always need to measure up through the UHF range reasonably accurately. So for me, the go-to watt meter for decades has been a Bird 43. This is kind of the service guys' standard watt meter. They've been making this thing since the 40s. It's basically a bulletproof case with a directional coupler in the bottom and a meter movement. And you take these slugs that you see in the picture here, you plug in the slug, and depending on which way the arrow points is the direction of the flow of power. And the meter will show you either forward or reflected power. And each one of these slugs is frequency dependent and has a maximum power. So you can imagine that this thing isn't cheap. So these things brand new are about $400. You can buy them used on eBay all day for a couple $100. The slugs cost somewhere between about $30 used to over $100. So if you really think, well, as a typical ham, I want a 100-watt HF slug. Oh, I want to do QRP also, so I'd like a low-power HF one, and I need one that's good on VHF and UHF. I got to buy 4 slugs. So before you're done, you're easily $400, $500, $600. So if you're setting up a professional two-way bench, this is always the go-to watt meter, and if you can get your hands on one, it's a good choice. But it's not necessary. You don't need to spend that much money. Surprisingly, they're not as accurate as you would think either. These are typically rated for 5% at full scale, at full meter deflection. 5%. That's not as precise. You think for $500, it would be like 1% or better. Not that you need it, to be perfectly honest, because most of us, all we're doing is adjusting something to go for maximum. You know, the fact that it says 98 watts or 102 watts, do you really care? Not really. You're typically looking for max or minimum on the reflected power. That's really the indication you're looking for. So this is a great choice if you want to go down this path. Another reason, by the way, to go with the Bird is there's tons of accessories. So if you want to sample the RF, you can get a Bird branded sampler. This is a little gadget that you put in line with your watt meter, and it will sample the RF energy, and it'll attenuate it by like 30 dB, and you can then take that signal and put it into a frequency counter or into a spectrum analyzer or some other instrument and not blow it up, and have that RF signal pipe into your instrumentation. So that's another consideration. We just did a great episode on watt meters with Doug Millar, K6JEY. It's like 3 episodes ago, and he goes into excruciating detail about all manner of dummy loads and why you would want one over the other, and some very simple ones to some very exotic ones, and good ones you can buy on eBay and so on. A couple of other suggestions that are a little bit more reasonably priced. You can go buy the typical Japanese Diamond or Comet watt meter. These are decent. They're not great, but they're decent enough. Like this one here is HF and it's VHF. A lot of them are dual ported, so there's like an HF in and out and a VHF in and out, so it does both at the same time, which is nice. They're usually under a couple $100. That's not bad. Anything that's below $100 is kind of okay, not great. So maybe better than nothing, but probably not great. Doug's choice for the best deal in an HF watt meter really tickled me. I'm a huge Drake radio fan. My first decent receiver I bought when I was a novice in 1973 was a Drake R4B, and I could never afford the T4XB to go with it. But if I did, I would have bought a W4 watt meter. And the funny thing was the W4 was Doug's top pick for a really good HF watt meter. You can find them on eBay for about $75 used. Obviously, I haven't made them for 30 years, but that's a great one to find. There's plenty of them kicking around. Okay, lastly, last a couple of thoughts here. It's not just about instruments and tools. You should also think in your workbench about the parts library. So when we go building projects, if we're just building kits and you get everything in a bag and you don't need to buy any parts, then you're kind of set. You don't have to worry about it. But if you're designing something from scratch, or you're building something from the handbook or an article, you're going to have to get a hold of parts. And the traditional place to get parts are from the big distributors like DigiKey, Mauser, Allied Electronics. You know the names. Personally, DigiKey is my go-to source, always first. Why? They have a phenomenal array of parts, in fact, too many, and their customer service is superb. Every time I place an order, the thing ships out in a day. It comes incredibly well packed. The me is they're really an industrial supplier. They're not a hobbyist supply house. However, I could place an order for 3 resistors, and they will pick them and package them and send them to me. I consider that a fabulous service to the community, and there's a whole reason for that. I found out quite interestingly. So you may or may not know how. Does anybody know how DigiKey got its name?
No, I don't.
So DigiKey. There's a gentleman, a fellow named Ron. I forget his call sign, but Ron is a ham. And about 30 years ago, Ron designed a keyer, a digital keyer. And Ron wrote an article, submitted it to QST. QST published it. It was called the DigiKeyer. And Ron decided that he would make kits. And so he bought parts and he bagged them up and he made kits available. Well, that turned into DigiKey. So DigiKey, that we know and love as this literally multi-billion dollar company, was started by a ham who made a keyer. Is that awesome?
Wow. Did not know that.
And I buy a lot of parts from these guys, and so I was talking to one of them. I know some of these guys real well, and so I talked to one of them one day. And I said, by the way, I just got to tell you, your prices are not cheap. I get that. You're paying the kind of list price, more or less. But I said, why do you guys do what you do? Why would you sell me a switch? And he says, we started out selling stuff to hobbyists. That's not really our main business, obviously, anymore, but that was kind of our roots, and we want to kind of honor that. And frankly, a lot of people that buy like 3 resistors work for a big company that are going to come back and buy, $1 million of the parts from us. And so like we're good with that. And so it's smart, obviously, but it was just great. I mean, it sort of reinforced my appreciation for these guys. So if they don't have it, I go to Mauser. If they don't have it, I go to Allied. That's kind of like my pecking order of suppliers. Now, besides those guys, there's a bazillion other sources of parts on the internet, more than you can possibly count. Obviously, the big go-to places are eBay or the offshore suppliers like Banggood and AliExpress. Amazing deals to be had there. You can get stuff shipped from China in almost no time. The other source, of course, is actually surprisingly Amazon. A lot of stuff that you would think would not be at Amazon because you think of it as more consumer stuff. I buy a lot of stuff on Amazon. I buy microcontrollers. I bought a box of stainless steel screws the other day. I mean, so Amazon's a great source, and a lot of that stuff is pretty quick delivery too. So that's a good source. The thing you want to think about in terms of parts is not only the suppliers, but what parts are you going to inventory yourself. Now, if you're not much of a builder and the thing you build is and the kit comes with all the parts, and once you've assembled it, you have nothing left over, hopefully, and the thing works, then you don't need a bunch of parts and you don't need to store them. You don't need to take up the space. But if you're like most of us, you start to accumulate parts over time. I need a 10K resistor. Oh, they're so cheap, I'll buy 100. They're like $2 for 100. So I'll just get 100. Now I got 99 left over, and so I need to put them in a bin or in a drawer or somewhere. So there's 2 things I want to mention here. One is I recommend to everybody who really gets into home brewing and bench stuff, build your stable of favorite components that you know intimately. Like pick your favorite voltage regulator. Know how it works, understand the components to surround the voltage regulator to make it work, understand what it's good for and not so good for, and if you do this long enough, you could bash together circuits in no time. So there's a lot of times when I'll talk to a friend about something, and then like the next day it's like, well, here it is, and they're like, how in the world did you come up with that so quickly? And the answer is that's just a combination of 6 little sub-circuits that I did years ago, and I just glue them together. And maybe it's a new circuit board with all of the discrete parts glued together, or maybe they were physically separate modules I soldered together. But the point is, you can really make projects quickly by reusing stuff that you get a familiarity with. Obviously, this is not a big deal for a resistor or a capacitor, but if you're talking about integrated circuits, power regulator being a good example of that, here's my favorite example. I'm going to build a circuit that runs on 5 volts. The electronics runs on 5 volts. The power source is going to be the typical Ham power source, which is 12 to 13.8 volts. How do I go from 13.8 volts to 5 volts? The standard answer that everybody knows who has ever built anything is a 7805. 7805 is a 3-terminal regulator. You ground the middle pin, you put 13.8 volts on the input, and 5 volts pops out the other side. Now, what's wrong with that?
That's a lot of heat loss.
Exactly. That's a lot of heat. That linear regulator is going to drop 7 or 8 volts times the amount of current you're pulling through it in watts. So if I'm dropping 8 volts and I'm pulling an amp out of that thing is going to dissipate 8 watts. That's a lot of heat.
Yeah.
That's too hot. It is too hot to handle. I mean, the most current you can pull through that part and not feel it is about 100 milliamps, even though those are 1 to 2 amp parts. So, well, okay, so for us, a 7805, anybody that says, I know how to do this, 7805, no, they don't know what they're talking about. That is a bad idea. Unless it's only running like one LED, fine. Anything more substantial than that, forget it. So what are you going to do? How about a switching regulator? Okay, there's only like 50,000 switching regulators to pick from. And every switching regulator has a different coil and capacitor and whatever. Or you can get a module, a switching regulator module with everything built in. Figure out which one of those does what you want. Why is the switching regulator good? I can put 15, 16, 20 volts into it, pull an amp out of it, and it never gets warm. That's a good part for a ham to know about. But pick one, and you know, I can tell you offline like my favorite one. So I have a drawer full of them. I got like 20 of the same thing because I'm always needing 3.3 volt and 5 volt parts. I mean, every project has 1 or 2 or both. So I know exactly what part I'm going to use. The other suggestion I've got is to look at parts kits. Parts kits are so cheap these days. It is unbelievable. You don't have to go buy the 3 bespoke resistor values for your project. You can just go buy a resistor pack. You know, you can go on Amazon or eBay, look for resistor packs, and for somewhere between $5 and $20, you can get more resistors than you'll know what to do with, of all the popular values. And it's well worth the, you know, $10, $15 to do that. You could do the same thing with capacitors. You could do the same thing to some extent with inductors. You could do it with transistors. You can do it with diodes. You could do it with screws. There's no reason not to have 15 different sizes of 440 screws and nuts and washers because they're so cheap. You can buy them in a kit. I mean, I don't know how they make a buck at this. All the way up to more complicated batches of goodies. Like if you really get into microcontroller stuff, and so many projects are based on microcontrollers today, you can go get breakout boards, which are little tiny circuit boards with one part on them, and get like 20 of them. You know, temperature sensor, a current sensor, an LED, a tilt switch, a magnetometer. We can build a beam pointing device, a compass. So you can buy like a whole set of those chips on little breakout boards with little jumper wire pins for like $30. So for, you know, starting at about $20 and maybe someday spending as much as a couple $100, you can build an incredible parts inventory really, really easily. Something that was just like impossible 20 years ago. So so I highly recommend that. If I ever get raw material, like I use a lot of heat shrink tubing because I build a lot of cable assemblies, you know, for Go kits and stuff like that. So I use a lot of heat shrink tubing. I like heat shrink with an adhesive, and you always need different sizes. You need skinny ones and middle ones and big fat ones. So I just buy a plastic bin that's got like 10 different sizes of heat shrink in it for like $12. Now I've got heat shrink for the next year. And sizes that I did, you know, you buy the size you need today. You don't buy all sizes normally. Well, this makes you buy all sizes, so you're kind of covered, just like the resistors. You know, you're going to get one of everything that you can possibly need, so you're pretty well covered. So that's a few thoughts on your components, and that kind of wraps the whole thing up. So I guess my summary comment is that building a bench today, first of all, it doesn't have to be super expensive. We did this show I mentioned. Building a bench from scratch for $250. I don't mean the bench itself, I mean the stuff that you use. And there's some wonderful examples of very high quality things you can pull together. So you can start very modestly and build your way up. The other beauty of it is that most things that you buy, you can use for a lifetime. I have a digital multimeter that I bought from Radio Shack when there was Radio Shack about 25 years ago that I still use today. I don't know why it still works. I'm surprised it still works, but I'm grateful it does. Power supplies, oscilloscopes, you can go get a 30-year-old Tektronix oscilloscope and it's a great scope. So these things will really last a very, very long time. So with that, if there's any questions, I'd be happy to take them.
Okay. Well, anybody have anything to ask? Don't be shy. All right, fine. The nice thing about the parts kits too is that unlike just a random box of resistors, they're labeled and they're organized.
Yeah, that's a really good point.
Because I mean, over the years, you just build up tubs full of stuff, and then when you need one, you're squinting and you're reading 40-year-old color codes versus like, oh, this bag is all 100 ohms.
Yeah, I have two kinds of bins. I have the bins that are sorted like this when you get them, and then I have junk box bins. So a lot of times I'm working on a project, and at the end of the project I have a few parts left over, and rather than sometimes I'll put them back in the bins where they belong. A lot of times I throw them in the junk box bin, and so that just grows into this big mound. And then at some point you kind of go to your, remember when we used to do club meetings? Like we'd go to the club meeting and like, okay, here's a bin, and just take a bag because I'm not going to sort them out.
Right, exactly. So, all right. Well, thank you very much, George. I appreciate this, and that was very good information. And like I said, we'll get this up on YouTube so the other members who weren't able to make it tonight will watch. And I recommend you go listen to the podcast. I mean, if you're interested at all in this stuff, that's fascinating. And I always learn something, even if it's you guys are talking way over my head sometimes, but I always learn something out of it.
Well, I always learn a lot too, because we try to get guests on the show that know a thing or two and could teach us all something. So it's a great way for all of us to learn. And even though we do kind of go deep on a lot of topics, we always try to also bring in the element of an introductory level to it, because a lot of people are getting into that for the first time, and we all were ignorant about all this stuff at some point, and you need to start somewhere, but we also try to paint the picture of where you can go if you really get into that topic.
Yeah, exactly. So, all right. Well, I appreciate you stopping by. Thank you very much for the presentation. That was great.
My pleasure. Thanks for the invitation. I really appreciate it.
You're very welcome. And I'll make sure you get a copy of this as well. So, all right, everybody. Thank you very much. Good night. And we'll see you. What?
I say good night.
Good night. Oh, there's Joe.
Good night, Paul. Yeah, we're here.
And we'll see everybody next week. So, good
73.
Night. 73.